Hey, welcome in everyone. It's Meteorologist Thomas Patrick here for Weather Classroom. A day late, but not a dollar short. Yeah, special Friday edition. Needed an extra day to get all the content ready. But boy, is this a good one. I'm really proud of everything that went into this edition of Weather Classroom. Hopefully you will be as excited as I am because let's face it, so many people have asked me already what the winter weather outlook is for this upcoming season, or really 2 seasons away. It's still summer after all, but yeah, it's starting to kind of crop up in everyone's minds. So I thought, hey, what the heck? Let's humor everybody. I know it's really early, but I think now might be a good time to at least maybe take a quarter of a look at it and what might be in store for this upcoming winter, because just so many people are at the very least curious about it. So this edition is on the winter weather outlook and a comparison between not just the forecast and the data that I put together, but actually comparing it to a couple of the more hyped up forecasts, if you will, the Farmer's Almanac and the Old Farmer's Almanac. So I'm going to compare all three of those and what they say about Spokane's upcoming winter and really a Pacific Northwest focus. But of course, it will have information across the entire country as well. If you love these weather classrooms, if you're brand new here or if you've been here every single time, please make sure to hit the like button on this video as well as my page. You get notifications when I go live so that you can join me here and just kind of enjoy the weather information and all that weather content that I can provide. So thanks again for all the support. I really, really appreciate it. And of course, if you have any questions about the outlook itself, or perhaps additional weather classroom topics, please make sure to leave them in the comments below here on Facebook or on YouTube as well. Okay, let's start with the more scientific half of this before we compare it to, say, the Farmer's Almanac and the Old Farmer's Almanac. And this is probably something that you've heard of before. Probably. El Nino and La Nina. Those are terms, those are weather terms that are certainly at least known by most people. Do you exactly know what it means? If not, I can explain that and just why that makes such a big difference when it comes to our winter weather forecasting. But of course, El Nino, which stands for the boy, and La Nina, the girl, are just weather terminology for the Pacific Ocean waters and how warm or cold they are compared to normal. And this is actually the current state right now. I love using climate.gov, which is the Climate Prediction Center, a branch of NOAA that just keeps an eye on all of the long-term, big global scale weather factors and makes those long-term predictions and outlooks for months in advance or even seasons in advance. So this is actually where our just kind of our base foundation of information comes from when it comes to winter weather forecasting. And why are we looking at the Pacific waters? Well, notice that the red and the blue shades represent how much warmer or colder the waters are than average. And it's actually very important that we look at the waters right near the equator, pretty much centered on this particular screen. And let's bring this over to here. So I've kind of highlighted this image and then actually drew the area that we watch in terms of where El Nino or La Nina is. It's those equatorial waters in the Pacific Ocean, as well as close to South America as well. And there's actually different sectors and sections of it. And right here, square in the middle, it's not too much of a signal. There's a lot more white, so it's pretty close to average, but you see a little bit more blue kind of hugging the equator. So maybe just slightly in the colder or the La Nina stage, but notice how it's a lot bigger of a signal on this side. And actually, when we look at the El Nino sectors, this is considered the 1 and 2 sector. There's a 3 sector, a 3.4, which is the most important, and I know that's kind of academic, and then a 4 sector. And they all kind of work together and in tandem, but right here in the middle is the most important. And usually a lot of the colder waters that start here closer towards South America actually start drifting into the rest. I know that's a lot probably to take in, but it pretty much breaks down to this, and I'm sorry that this one word got cut off in my dual box here. But essentially what it is we look at the temperature anomaly of the equatorial Pacific waters to determine the phase of El Nino or La Nina. And El Nino is when it's warmer than average, and La Nina is colder than average. That's important because it has an effect on our winter weather forecasting in the United States and really across the world as well. It is the single most important factor, and there's some others that go into this as well. It can also be described as either weak, moderate, or strong phases as well. And it's just a half a degree Celsius or about 1 degree Fahrenheit that makes the difference for a weak, and then 2 degrees for moderate, and then 3 degrees for strong, or half, 1, and 1.5 Celsius for those categories as well, in both directions. So if it's minus 1.5, that's a strong La Nina, and if it's plus 1 degree Celsius, then that's a moderate El Nino. So we can categorize all of that, and it's just really fascinating that we have all this information at our disposal. So here's the effect. We look at the Pacific Ocean water temperatures, and then we have analyzed this over the years. We've been watching this since 1950. We have data that goes back for 70 years on this. And there's some pretty much just basic foundation or kind of ground rules, if you will, with how the jet streams are oriented across the United States during the winter months. This is, of course, broad. We're talking 90 plus days, but it kind of ends up being like this more often than not. Not perfect, but more often than not. So you have the La Nina and the El Nino phases, which, by the way, the true name for El Nino is El Nino Southern Oscillation, or ENSO. And of course, if it's positive, it's El Nino. If it's negative, it's La Nina, and we get this kind of breakdown here. So let's compare now with what I think is going to happen and what the Climate Prediction Center thinks is going to happen versus the almanacs parts of the forecast. And you should know that we are forecasting a La Nina stage for this upcoming winter. And by the way, when you compare these two, La Nina usually favors a colder and wetter northern U.S. and a drier and milder southern U.S. And it's almost kind of the opposite in the El Nino. A stronger subtropical jet stream means the southern U.S. is usually wetter and probably colder than average. And then it can be milder at times for the northern U.S. as well, and perhaps drier, but it's not as strong of a signal. Okay. So I think my next graphic here is our typical La Nina pattern with a focus on the west coast of the U.S. As I mentioned. So when the waters in the Pacific Ocean near the equator are colder than average, we get this high pressure area that gets anchored in the northern Pacific. It just happens more often than not. So you get the jet stream that kind of dives down the Canadian west coast and into the Pacific Northwest. This usually provides a lot of extra moisture, a maritime polar air mass, which is usually colder and wetter, or in our case, snowier than average. So I think that's how this leans for this upcoming winter. Of course, most of the northern plains is going to be very cold, and then parts of the Midwest and the Great Lakes, again, can be colder and wetter or snowier than average based on how the climate kind of breaks down. This is the most favorable pattern for this upcoming winter. I know it's September right now. We're 4 months before we're even into truly winter conditions. But it's nice to have kind of an idea of what's going to happen. But let's compare that to some of our other forecasts. And I want to compare that to, first of all, the Old Farmer's Almanac. Here's the Old Farmer's Almanac, which I believe came out 2 weeks ago. And when you look at the terminology here, I hope you kind of giggle at it as much as I did when I first saw it, because I laughed at it, to be honest. Check it out. It says gorgeous for Florida. I mean, Florida in the wintertime is pretty nice. People vacation there for a reason, right? Snow dumps in the upper peninsula of Michigan. That makes sense. They average about 200 inches of snow every winter. They get snow dumps all the time. New England, it's snow time. Yeah, that's called winter. It's winter in New England. They get snow. They get lots of it. And even look at the Pacific Northwest coast from Seattle, Portland, Washington, and Oregon coast. Wet, you bet. Yeah, the winter months are the wet season for the Pacific Northwest. And of course, on the western sides of the states of Washington and Oregon, it rains more than it snows. I mean, I think Seattle only even averages a couple inches of snow a year. It rains more than it snows. So honestly, this is winter. I mean, it's not going to be summer in winter now, is it? So that pretty much is just like, yeah, it's going to be winter this winter. So I kind of giggled at it when I read all this terminology. Now, the Farmer's Almanac, not the old Farmer's Almanac, just the Farmer's Almanac, has terminology that's a bit more quantifiable. When you see words like mild dry for the Pacific Northwest, you can quantify that as, oh, above average temperatures and probably drier and less snowier than average. But note how that directly conflicts with the forecast that I just presented with La Nina. So, which way is it going to go? And as a meteorologist and a scientist, I have to lean towards the La Nina pattern because it does happen more often than not. It's not like that in other parts of the country. Notice how the northern plains say is cold above normal snowfall. That does fall in line with the La Nina winter. So it's kind of like, okay, I'm personally, as a scientist and a meteorologist, I get mixed signals from this. And kind of the same thing with, again, like the Florida, the southeastern U.S., it says chilly and showery. That would conflict with the La Nina pattern, which usually offers drier and more mild conditions for the southern U.S., not the Pacific Northwest. So it can get confusing. And I know that sometimes it feels like these outlets can hype up the winter forecast, but I don't know if it holds any weight. So let me also try to prove to you why the science actually does hold weight, as opposed to just randomly throwing out a forecast. I know somebody can be like, well, you're just saying La Nina could happen. Well, let me prove that to you. Going back to the Climate Prediction Center, we're under what's called a La Nina watch. And it's the computer models that the National Weather Service and NOAA has on this showcases that this is probably the direction that we're heading into the winter time. I kind of mentioned that you notice these colder waters near South America. That usually drifts into and affects how the rest of the El Nino areas, or the ENSO areas, are impacted in the months ahead. So I also believe that this is going to end up being a La Nina winter. I don't know if it's going to be weak, strong, or moderate per se, but it is definitely the direction that we are heading. So yes, that leads me to believe, to go back to this map, that we should be in for a colder and wetter season. And then how do we know if this is true? Well, here's the fun part. And I get so excited when it comes to data. I went over the last 20 years, and I could have gone even farther back, but it got a bit overwhelming to look at so much data, because I was looking back at all of the La Nina years from 1950 onwards, and I compared that to the strength of the La Nina year, the temperature during the winter season in Spokane, and how much snow we got throughout the course of the season. So I tried to consolidate that into a bit more digestible cross-section. So these 9 years that I picked out of the last 20 are all La Nina winters in Spokane. And I also plotted them, of course, with the average temperature for those 3 months. That would be December, January, and February, and how much snow we got through the entire season. So that would also include any early season snows in November and any late spring season snows in March and April. And what really stands out here, for anybody that has ever lived in Spokane for the last 12 years, you probably remember the winters of 2007, 2008, and 2008 and 2009. Those winters, we had more than 90 inches of snow, almost double what the normal snowfall total is for Spokane. And those were both La Nina winters. In fact, I can even go a step further here and show you that 2008-2009 season, that was the record snowiest season ever in Spokane's history, which records began, and I have it cut off, but it's 1893. So about the last 127 years, if my math is correct, 127 years, and that was the snowiest season ever in the wintertime in Spokane. And even the year before, 2007, 2008, which was actually a very strong La Nina year, the third snowiest. So we had back-to-back La Nina years with the third snowiest, which at the time was the second, and then the snowiest year ever. And there are more often than not, this is the case. We also had 69 inches of snow in 2010 and 11, and 61 inches of snow in 2016 and 17. It's not a perfect correlation. Notice how in the years 1999, 2000, 2005, 6, and 2011, 12 actually didn't end up being colder and snowier than average. But about 2/3 of the time we do. And there's this really high-end potential because some of these years, when you're talking 50, 60, 90 inches of snow, that can be quite significant. It's not obviously not guaranteeing we're going to get 90 inches of snow just because it's a La Nina year, but that high-end potential is there. When we get La Nina winters, we get a potential for a lot of snow, but only about 65, 70% of the time. So that's how it breaks down, and it's in a lot of these times, and to no surprise, and it should come as no surprise. When it's snowier than average, it's also colder than average. Or when it's colder than average, it's also snowier than average. Those things come hand in hand, and it does correlate every single time. In fact, I'm sorry I'm covering this up. And in fact, if I go on this side, you can see that the 2016-17 year was also the 10th coldest of all time and 25th snowiest of all time. So top 20% of snowiest years. So those go hand in hand. The cold and the snow come hand in hand. And then the opposite is true too. When we don't have as much snow, it's also milder weather, or vice versa. So they correlate together. It's not perfect for La Nina, but about 70% of years do happen to fall this way. And that's what I found so interesting when I was poring over the data here, that La Nina winters can be very, very snowy. By the way, we just got a brand new audience here on Facebook. First of all, hello everyone. This is Weather Classroom. I'm meteorologist Thomas Patrick. If you're just joining me for the first time, welcome in. I'm talking about our winter weather outlook, and I know it's going to be like 95, 96 degrees today, but a lot of people have asked me, hey, what's going to happen for this upcoming winter? Would love to go over the information here with you all as well. And if this is your first time joining me, please do make sure to hit the like button as well. I want to humor everybody for just a little bit because, again, so many people had asked me about the winter weather outlook already this year. And I was like, it's a little early for that, don't you think? But people are curious, and honestly, that got me curious as well. And it turns out we're probably in for a La Nina winter, which usually ends up being colder and wetter and snowier than average. So this is how it usually breaks down across the U.S. just based on the average conditions and the typical orientation of the jet stream. Gives us a bit more Pacific moisture, a bit more colder air as well, a maritime polar air mass on the norm for the upcoming winter. So I do think this can be a colder and wetter and snowier winter than normal, which actually is directly the opposite of what the Farmer's Almanac had just released come last week. And to show that, so this was the Farmer's Almanac prediction, which has the Pacific Northwest as mild and dry for this upcoming winter. And when I first saw that, I was like, really? We're in for a La Nina winter. So I think we're in for actually the complete opposite conditions. And I noticed when I first posted this on Facebook last week, quite a few people were just like, are you sure? Like, can you prove it? And I'm like, I've got science on my side. So allow me to run through the science with you all. Because let me explain first just what El Nino and La Nina is, because those are probably terms that you've heard before. And what it is we look at the Pacific Ocean water temperatures, particularly right around the equator, and compare if they are warmer or colder than average. This is the current phase, or at least the last analysis, which was the July 2020 analysis. And you can probably see that the waters are a little bit more blue right around the equator than not. So we're starting to trend towards La Nina, the colder waters than average. And that alone has an impact on how the jet streams are oriented across the entire globe, for that matter. So that's why when we have that kind of conditions, we end up with this type of weather pattern where we start to see colder and wetter and snowier conditions in Spokane and across most of Washington, for that matter, in the Pacific Northwest, than what is normal for a winter season. And I took that information and said, okay, let's compare La Nina winters past and how cold and how snowy they were in Spokane. And that is where this list came up with. So if you just tuned in right when I drew this list, this is the 9 La Nina winters we had in the past 20 years, since the year 2000. And I compared exactly what the average temperature and the snowfall was during the winter time in Spokane for those winters. So we're looking for colder and snowier than average. And 6 out of those 9 years, we were definitely snowier than average. And in some of those cases, a lot snowier than average. How many of you remember 2007, 2008, and the winters of 2008, 2009? 90 plus inches of snow. Both were La Nina winters for Spokane and for the inland Northwest. That ended up being the #1 record snowiest winter season and the 3rd snowiest year of all time in Spokane. There is a high-end potential for a lot of snow when it comes to La Nina winters. And actually, what's kind of interesting enough, the 2007-8 winter was a strong La Nina, and it kind of lasted in 2008, 2009, but it actually was a lot weaker, but the signal was still there. So what I'm saying is that there's not as much of a correlation with how weak or strong La Nina is. We just need La Nina, and we start to see this kind of correlation. It's not 100% correlation. It's about a 2/3 or about 70% correlation. But when we get La Nina winters, we're usually at least around average. In fact, one of those years, the 1999-2000 year, see 41.2 inches of snow. That's pretty close to average. A little bit less in that 2006-2012 seasons, but usually we're either close to average or well above average in terms of snowfall, and then it ends up being colder as a result as well. So that's why, and hopefully that makes you guys here in the weather classroom understand that yes, La Nina winters end up being colder and snowier more often than not for Spokane, all of Washington, really the Pacific Northwest, and most of the northern U.S. for that matter. It's those broad patterns that take shape and usually take over our weather pattern. I can't sit here and say, hey, we're going to have a huge snowstorm on January whatever. But these are just the overall patterns, and the data supports it as well. So to recap and wrap up Weather Classroom today, the El Nino and La Nina is called ENSO, El Nino Southern Oscillation, and the Pacific water temperatures determine that phase, whether it's warmer than average for El Nino or colder than average, and that's La Nina. We're forecasting with fairly high confidence that we're in for a La Nina winter this year. And that typically means, as you just saw the data, colder and snowier in Spokane than average. So that's just where it comes from. This was an entire day of research and data collecting on my end to be able to present this to you. So hopefully you found this as interesting as I did, because I had a blast looking up the data. I love numbers. I love graphs. I love looking up that information. It's really exciting for me, and it's really exciting to be able to present this as well. I pretty much just did everything short of an entire journal article on it. So hopefully everybody enjoyed that today. That will wrap things up for Weather Classroom. I am a little bit over time. I got to give Tom Sherry access to the weather computer now. But thank you everybody for tuning in. If you're still sticking around, please make sure to hit like on this video. And if you haven't liked my own Facebook page yet, I would certainly appreciate the follow there as well. Weather Classroom is usually Thursdays. Today I needed an extra day to work on the data, but usually Thursdays, sometimes Fridays at 1 p.m. right here live on my Facebook page. And if you have liked my page, you will get the notification when I go live and be able to ask questions on the fly. I didn't see any questions today, but I really do appreciate you all for sticking around and sticking through the presentation. Hopefully you learn some little table talk, so the next time you gather with your friends, social distance, with a social distance lunch, you can be like, hey, did you know that 2008, 2009 winter was a La Nina winter? You can really impress your friends with that kind of knowledge. All right, that'll finish things up for today. Again, thanks everybody for tuning in. And if you have any topic suggestions, please make sure to leave those in the comments below. Thanks again, everybody. Have a wonderful weekend. Stay cool out there today. It's going to be like near record highs out there for this Friday. So enjoy summer while you can. And of course, we'll keep an eye on the wintertime for all the rest of you. Thanks, everybody, and we'll see you later.